Hey everyone, I'm going to work a couple problems out of Mastering Chemistry Chapter 15. If you've already finished that, you can ignore me. If not, maybe this will help you. But they're all equilibrium problems with ice table. And so this first one, you can identify its key concept video. And it asks you, it gives you the reaction between, decomposition reaction of hydrogen iodide, decomposing the hydrogen and iodine. And it tells you how much hydrogen iodide you started with and asks you for the equilibrium concentrations of hydrogen and iodine. And so first of all, when you're doing equilibrium problems, it's important to know when to use an ice table. You use an ice table whenever equilibrium concentrations are not given. So if you read this question, it just says you place HI into a container and it tells you how much you placed in, but it does not tell you how much was left to equilibrium. So that means you need an ice table. And so I'm going to shift over to where I work this out. Okay. And so what I do for an ice table, I just think it's easier. I write the balanced reaction at the top of my ice table, and then I just fill in all the information that the problem gives me. And really all this problem gave to begin with was the initial concentration of hydrogen iodide, which is 1 molar. And so if they don't give any of the equilibrium concentrations, you need to use X. And so if it's a reactant, it's minus X because the concentration is decreasing. And always assume the concentration of products are 0 at the beginning, unless you're told otherwise. And since they are products and they start at 0, plus X. Now, in this X row, you need to pay attention to the coefficients of the balanced reaction. I can see I already messed this up. Hold on. And so notice there's a 2 in front of the hydrogen iodide. So that is minus 2X. Products are increasing, so they're plus, but notice there's only a coefficient of 1 in front of each of the products. So that's just X. And then you simply add each column up. 0 plus X is X. And 1 minus 2X, let me correct myself here, is the equilibrium concentration for hydrogen iodide. Okay, so once you get your ice table finished, go ahead and write out your equilibrium expression. I encourage you strongly to go ahead and write this generic expression in terms of products and reactants, because it's so common for students, if they don't do this and just start plugging in values, you're going to forget if there are exponents, okay? And look at the reaction. Remember that it's the concentration, and if there's any coefficient in front of it, that becomes an exponent, so be careful with that. So now let's plug in the values, and gosh, I gotta correct myself again. Okay, so the equilibrium concentrations of the products are just X. Equilibrium concentration of the reactant is 1 minus 2X. And now we're gonna talk about neglecting X. On all of the problems I give you using an ice table on my test, you will be able to neglect X. However, I need to warn you that on your final exam, I've been told by students that there are about 2 equilibrium problems that require a quadratic equation. So let me walk you through this. All right, so here's the expression for K. They give you the value of K, 1.6 times 10 to the minus 3. And how do I know when I can neglect X? It turns out that if the initial value, if your initial concentration from which you're subtracting X is about 3 orders of magnitude larger than the value for K, and in this case you're right on the border, then it's usually safe to neglect X. So you're looking for a difference in 3 orders of magnitude between these 2 numbers. So again, you're right on the border. So let's go ahead. And I'm going to show you how you can check to make sure that it was okay to neglect it. Let's go ahead and simplify this mathematically. Okay, so now we have x squared on top. We've neglected the x, so we just have 1 on the bottom, and equals the value for k that they gave us. And then we're going to solve for x, and we get 0.040 molar. How do we know? Let's say we just assume we neglect x. How do you know if it's okay to neglect x? Again, I'm not going to ask you this on my test, but your final exam will have it. It's called the 5% rule. And basically, the ratio of whatever you got for x divided by the original concentration you're subtracting it from, okay, which in this case was 1 molar. If that ratio is less than 5%, you were okay to neglect x. So let's check. Value we got for x is 0.04. The original concentration was 1, and that's only 4%, which means it was okay to neglect x. So the correct answer is in fact 0.04 molar. I think that one of the option you choose is 0.038 molar or something. I don't know. Everyone has slightly different values in mastering, but that's the process you go through. You may want to write down the quadratic so that you get yourself refamiliarized before the final exam. Again, you won't need it on my test. I think, well, I worked a sample quadratic out here. I'm not going to drag you through it, but it is here if you want to refer to it later. So basically what I did, no, I'm not going to show you that because I made this 2x mistake, so scratch that.